My name is Rishabh, and I just want to briefly introduce myself before going over the agenda. Uh, I am a staff machine learning engineer and researcher by profession, and specialize in domains like ranking, recommendations, and AI-driven personalization. I've previously worked at Twitter and Amazon, and currently I'm a machine learning tech lead at a late-stage startup, driving efforts to apply deep learning, generative AI, and agentic AI to personalize conversations in commerce space. So that's a little bit about me. Let's move on to learn about what is agentic AI. So let's take a quick journey through the last decade of AI. This slide essentially captures a powerful story of how machines move from simply recognizing images to making decisions and using tools in just over the last 10 years, 10 plus years or so. So in 2012, everything kind of changed with the advent of AlexNet, which was a deep learning model that drastically improved image recognition. And suddenly, machines could see with near human accuracy. We call this phase the beginning of perception AI, where systems learn to process and interpret visual and textual data. Over the next few years, AI was no longer limited to just classification tasks. It could now analyze, interpret, and even respond to information. Teams at Google DeepMind, MIT, CCL, Stanford, and others kind of pushed the envelope further. The next big leap was within like generative AI in late 2022. ChatGPT was brought into this generative AI field. Um, and then suddenly AI wasn't just like analyzing content, it was able to like create it. Platforms like Hugging Face, Copilot, Anthropic, and Meta's Llama help democratize these kind of capabilities. Uh, and now, 2023 to the present year, we are now entering in the agentic AI era. These systems don't just like generate content, they can act autonomously, make decisions, and use different tools to complete various tasks. So think of these AI agents as like a personal assistant which can take actions on your behalf. And then that's where, in that context, we'll kind of learn about tools like Langgraph, which can help you build these kind of agents. So let's dive a little deeper on understanding the agentic AI aspect specifically, and learn how they are fundamentally different from the previous AI paradigms. Um, in essence, agentic AI is a composite system, which is not just an LLM, but it consists of like many other things. It does use LLMs for natural language understanding and reasoning, but it has other aspects as well. For example, like planning modules, which can plan kind of different tasks. There is a tool execution layer which will use different like functions or OpenAI schemas. It has memory baked in and state managers, which will allow us to track multi-turn reasoning in like various types of tasks. So all that is to say that agentic systems are autonomous. They can operate with minimal supervision. They are goal oriented and can interpret abstract objectives. They are adaptive. Let's say if they're in action and they come across any errors, they can update the tasks they need to do to achieve the ultimate objective. And they are also proactive. So they trigger workflows based on like various conditions, which are not just purely prompts which LLMs kind of work on. So think of it as a layer on top of LLMs that would combine planning, the usage of various tools, usage of memory, and then control the software flow um, into a cohesive environment. So it is a full-fledged kind of applications built on top of LLMs. So with that understanding, let's make this a little bit like interactive. So in general, uh, feel free to answer in the chat what we want to essentially distinguish here is how the agentic AI workflows are different from traditional AI workflows. Traditional workflows would just mean like you using LLMs, using the prompt given. So the first option says traditional workflows uses multiple steps, maintain memory, while agentic AI workflows are stateless and singleton. Um, Option B is the reverse of it. The third one includes vector databases, external tools, while agentic AI does not. And then agentic AI eliminates the need for structured steps and instead focuses on deterministic outputs. Cool. So yeah, I think yeah, unanimously I am seeing B as the correct option, although there are like a few guesses on the other options as well. But yeah, mostly option B is the correct one here because agentic AI kind of introduces structured goal setting, tool integration, and memory, which also uses, let's say, vector databases under the hood, and they can plan logic dynamically and produce like more efficient workflows to handle any tasks. So yeah, the main distinction is traditional AI workflows would be uh, not using any tools under the hood. They'll just like purely rely on the model, whereas agentic AI workflows would have a set of tools available. Cool. Now that we know a little bit about agentic AI, there is a concept of vertical agentic AI or vertical AI. So let's understand what that means. And that is actually related to the demo that we'll be kind of doing today. So in general, vertical AI represents a specialized application of agentic AI that is tailored to a specific industry or domain. So basically, these systems are specifically trained or fine-tuned on industry-specific data, for example, retail. They often incorporate domain-specific ontologies and knowledge graphs, and then training data may look like, for example, in healthcare, it could be like medical literature and clinical guidelines. For legal domain, it could be legal codes, precedents, and contracts. So this specialization often requires custom data pipelines, cleaning procedures, and annotation schemas. Um, Essentially, they integrate well with any different kind of industry systems and workflows, and then they deliver like higher performance for those kind of specialized domains because these are adapted on that specific domain's data, so they understand the context better. And we do also have specialized prompt engineering techniques for industry specific kind of queries. So rather than having like something like really broad, which could do like okay across different industries, what we try to do is we pick an industry and make something that is really specialized so that we are able to tackle any enterprise based problems and expect a higher accuracy on those. So till now, we kind of talked about vertical, first of all, like AI agents and talked about like vertical AI. Now let's shift a little bit and move into to see how um, these kind of agents are transforming various industries. So in general, based on this slide, there was a recent survey from Boston Consulting Group where they kind of showcase that AI agents are the future. They are kind of gaining traction quickly across an array of business applications, and the market of AI agents is expected to grow at a rate of 45% CAGR, which means compound annual growth rate over the next 5 years. So as AI agents become more commonplace, humans will closely work with them as teammates. Some of these shifts you might have already seen in your workplaces as well. AI agents will be onboarded just like any like human workers to learn roles and responsibilities and access relevant company data and business context, and will be integrated into various workflows and support humans that they're kind of working with. So I think um, in general, some of the folks are also asking the applications of agentic AI across various kind of verticals. So hopefully this slide provides you some helpful context. So in general, it could be applied in like various domains. Some examples in marketing, various leading consumer packaged good companies will use AI agents to, let's say, create marketing specific blog posts that could reduce costs by 95% and improve the speed of publishing those blog posts by almost like 50x. So something like that used to take like 4 weeks. Now it could be done in one day. In customer service, we can build various AI agents to interface with customers because these AI agents will have the knowledge of uh, the enterprise data for specific settings. So they can also reduce the cost by 10x because we won't have to like hire that many human agents as such. In research and development, uh, again, like we can reduce the cycle time by 25% and we can improve the efficiency as well. So there are kind of numerous examples. And in the interest of time, let's also kind of learn why uh, it is good in an enterprise setting, but why you should be kind of learning about these agents. So first of all, like learning agent building skills would offer you like strong career and technical benefits. Demand is kind of quickly rising with 300% increase in job posting with like certain kind of salary premiums as well for these kind of new roles like AI engineer and LLM ops engineers emerging across the industry. And then the early adopters of agentic AI frameworks would report a huge cost saving and up to 3 to 10x kind of productivity gain. So that would provide you a competitive edge in the industry. And then agent building would also enable like custom automation for unique tasks. So that could essentially kind of future proof the skills that you'll kind of gain if you kind of try to learn about this topic. Um, this slide would essentially show like top tools and frameworks that you could learn. So there are like different areas in which like you can focus. Um, I won't kind of dive deep into each of those, but based on like today's topic, we'll be kind of briefly here kind of talking about the AI agent builder tools, and then we'll have a demo which kind of showcases this in action. So that is the third card here. Essentially, hands-on agent building would involve tools like LangChain, Langgraph, N8N, or CrewAI, where the emphasis would be more on kind of building the agents, testing, debugging, and evaluating it using tools like Langsmith. But there are like other domains which you can dive deep into. First is AI and prompt engineering, where you can like iterate on the prompts itself to optimize the performance. There are like various like AI productivity based tools, and then all of that could be used to build scalable AI systems as well. But for today's session, we'll be focusing on the third aspect, where we'll see how we can build AI agents using the tool like LangGraph. Before going on to the demo, just a brief blurb on what you can expect from LangGraph, which is an open source automation tool designed to build powerful and custom workflows. So the key ability of LangGraph is that it connect to wide ranges of apps and services easily. For example, Google Sheets, Slack, Airtable, or any sort of like database you might have, and various LLMs like GPTs and llamas and so on. And this ideally kind of makes it very easy to integrate both AI and non-AI systems under a unified workflow. It is also built with a no-code, low-code interface. So if you're not a developer, you can build and automate sophisticated workflows without having to write a single line of code, which is also really nice. And then it provides you ability to build and manage autonomous agents, and it has both self-hosted and cloud deployment options as well. So before we move on to the demo, let's do like a quick quiz on based on the things we have talked about so far. So for the first one, it says AI agents rely solely on language generation and do not interact with external tools or APIs. So I think yeah, this one might be straightforward. I'm seeing unanimous answers. So yeah, this one is false. It is the traditional AI workflows that don't interact with any external tools or APIs. Agentic AI, on the other hand, would interact with such things. And then for the second question, agentic modern AI agent architectures would use workflows like branching logic, retries, coordination between multiple agents, and so on. Cool. Yeah. So yeah, second one is true. That is something we'll see in action in the upcoming demo. So yeah, thanks for engaging on this. And now let's switch to a demo that we have built in Collab, and we'll be seeing how we can build a retail AI agent with Langgraph. We'll be coming up with uh, a multi-agent system, and then we'll see how we like orchestrate that using Langgraph. So let me like resize my screens a little bit. So do let me know if in case things are not visible, but I hope the current font size is good enough. Cool. So in general, yeah, our goal for this demo is to just showcase how we can build vertical AI agents. So in this case, the domain is retail, so that's the vertical we are working with. And then what we try to do is build three agents, one around like product availability recommendations, other around order tracking, and the third one around return policies. Uh, and then we'll kind of use all these three agents and build one unified interface, which we orchestrate using uh, 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 a tool like Langgraph. So I won't go into details of what libraries and things we're doing here. Just in the interest of time, we have created one custom data set, and that is something we'll be kind of using. It is a retail data set, so it's about products and the order is placed and various kind of information. But think of it as this way, like in enterprise, you will have these sort of data sets available that you can query. And then what we want to focus here is how we can build different agents here. So uh, as the first thing, usually like what we had mentioned was that these AI agents will be having access to some tools under the hood. So in general, think of all this logic kind of working to kind of build tools which each of our agents could use. As I mentioned initially, we'll be creating three agents. One is product availability recommendations, second one is around ordering, and third around like return policies. So as the first thing, we are just setting up our LLM. We are using OpenAI's GPT 3.5 Turbo under the hood. And then this is something we will use as a fallback, but uh, essentially this will provide you some static response in case LLMs fail. Uh, so this is not very interesting. So let's move to the interesting part. So we next up we are building three tools. So the product agent will use this search product tool, and then we have the order agent tool that we'll be building later on, but that will use the track order tool. And then the third one is the return policy agent, and that will use the get return policy tool. So in general, if you look at some of the logic here, search product in general will take a query, and then it is kind of going through various logic where it will kind of search for product in the data set based on, let's say, the brand or the category or various kind of keywords and description, and basically different price ranges. So we have this like tiered system, but like we could implement it in a different way based on what works best for our enterprise setting. But essentially, what we are doing is we are trying to make the search as relevant as possible. So we can use some rule-based techniques. We can use some custom APIs we have built, anything like that. And then ultimately, what it'll do is it'll try to return some inventory information along with all the other details around name, description, and categories. Similarly, for order agent, we have, let's say, this tool. In general, in this case, it'll kind of look up an order based on order details, let's say using the order ID or checking for customer name, right? It'll try to kind of iterate on it and try like different ways to see if it can find the order that is kind of mentioned. And the for purpose of this demo, we choose like a random order if we are not able to like find it. But there are like various ways to like implement it correctly in an enterprise setting. And lastly, we have the get return policy. So essentially, it'll just fetch like policy information based on various product categories that I mentioned. And these tools will essentially be used as functional backends for the agents that we try to build next. So um, now that we kind of covered what tools we have available, we want to build agents which can use these tools. And previously, what we have discussed is agents are a collection of tools plus LLM. So this is something we'll see in action. In general, the first thing we are doing here is defining a retail agent state. In general, it is a type dictionary that will hold all the information between different parts in our flow, like messages, what the actual agent we are kind of using, and then what are the results we are getting, and all those things. So we'll see this in action as we go through the demo. And then we are coming up with like some system prompts. This will become like more apparent, but if we are building a product agent, then we want to give this type of prompt, which essentially clearly kind of dictates what the responsibilities are, so that when we provide it the tool, it can use this prompt and use that tool to fetch and identify relevant information. So this will essentially just like constrain um, the outputs that we are going to see from LLMs. Now, the first piece in building the agent is here. So this is where we are actually defining the agent, which is gonna use the tool that we had defined previously. So as you see, the first thing it is doing is like it is kind of fetching the query and using the tool that we had built. Now, search product, it is a simple function here, but like in an enterprise setting, it could be as complicated as possible, right? So we can have like anything under the hood, and we can also have like not just one, but like multiple tools available to kind of facilitate the use case. So in general, this product agent is using this tool to find relevant products, and then it uses LLM to uh, as we can see, uh, we we got the product info, which is kind of returned from the product results, and then it is using LLM under the hood along with the product agent system prompt we had provided to actually construct the response for the end user, right? So if let's say the query was, I want to find, let's say iPhone 15, I want to get the specs of iPhone 15, right? So essentially provided this prompt and provided the details of the iPhone I'm getting from here, I'll be able to get the details, something like this, and then that could be refined by the LLM that we have under the hood. So essentially, again, like AI agent has LLM, and then it has an access to a tool which can access your enterprise databases and fetch relevant information. And we'll kind of see shortly how the response kind of comes up, which is kind of relevant to the query. Then I think, yeah, so that is to the extent to it. This entire thing is one agent now, right? So what we are returning is all the kind of messages we received from the user and the results we had, and then the final response that will be served to the end user. So similarly, we have an order agent, and then this is using the track order tool under the hood. And then again, it's using the LLM the same way the previous agent was using with the order agent system prompt this time. And then after um, accessing the database, finding the information. If it is not able to find, it'll give you a response, something like this. But if it is able to find that, it'll give you a proper response. And finally, the returns agent, again built in a similar way. It'll use get return policy tool and the corresponding returns agent system prompt to handle the user query here. So uh, these are the three tools, but the part of creating a multi-agent system is once we get a query, we would need to kind of identify which agent should be the one that should like handle the user's query. So that's why we have an additional node. So we are talking in the terms of like Langgraph, which can orchestrates like various nodes, define dependencies, and kind of do the execution based on the user query. So this router would be at the top, and it'll basically try to define which agent this query should go to. So again, this is a type of uh, this is again a type of agent, right? So we have a system prompt here as well, which will say that given the customer query, I need you to identify which type of a query it is. We have provided some examples here, and then we use this directly in the LLM to define which agents I should be routing this information to, right? So this kind of task is simple enough so that we can use our generic LLM to identify what should be the best type of agent to handle this. But this could be as complicated as you want to make it. Again, we are using the same structure, but like giving the LLMs like different types of tasks, and then based on the responses we decide what we need to do next. Cool. And then I believe the notebook would be kind of shared with you, but in general we are doing like error handling and fallbacks and all the places. So if let's say the LLMs are not available for whatever reason, we want to have some fallback. So we can use all the keywords and then accordingly decide what agent would be the most suitable. So now we have a router, we have three agents. So that's where the Langgraph library would be kind of really helpful. Within Langgraph, what we will do is define a workflow on how these um, agents or nodes would be um, connected, right? So in general, what we are doing here is we are adding all the agents and the router we had created into the LangGraph workflow as a node. right? And then in the next few lines, essentially, we are setting up some conditional edges from the router node. So this means that after the router decide which agents is appropriate, the state will flow to that specific agents node. If it is a product based query, it'll flow to the product agent, otherwise to order agent, and so on. uh, the router is essentially set as the entry point. So any kind of query would have to go to the router first. And then uh, once we have done that, like we just like compile the workflow, and that should like orchestrate this multi-agentic AI systems for you, right? So again, like with these kind of libraries, now it has become like really easy to orchestrate let's say various aspects and various types of agents. And then we can keep adding like new tools. We can improve the prompts to make sure that we are handling the user queries in the best way. Cool. So just in the interest of time, I think it'll be beneficial to also see these things in action. So I'll try to cover the remaining material quickly. But yeah, mostly it is kind of boilerplate. After, let's say, we orchestrated everything, we have some logic where we can like visualize how the nodes are kind of constructed. And as a user send a query, it should kind of show me like what nodes are activated. So all this logic is to kind of come up with a UI that can showcase me. Let's say if I use the product agent, it should show me that node in green color. Others would be like yellow and red color, and so on. um, and then lastly, we are using Gradio here to kind of construct an interface that we can like interact with. So this is something I'll be kind of showcasing you today. In general, uh, essentially, Gradio would require you to define various functions. The first one is the respond function, which will be the main callback for Gradio. It will be kind of triggered whenever a user will send us a message. Um, and then it will update the chat history and store some of the details around the last trace of what agent is kind of handling the query, so that we can also display that in the UI. We have some other functions around clearing the chat history. So again, I think like in my slides, I'd mentioned these AI agents have access to tools. And they also have memory. So memory just means that what has this like user asked in the past, right? So we can keep a track of it if we want to make the responses more contextually relevant. And then we have some functions around just kind of visualizing the agent flow, and then something to test the connection of the LLMs. So yeah, after this, mostly we are kind of orchestrating what we have um, set up through the Gradio interface. So let me try to like pull that up and show you like how it kind of looks like in action. So I just like did a few things previously, but in general, let's say if I send it like any query, so let's say I want to ask about show me the specs of iPhone 15. Okay. So let's see. So as the case with like live demos, something is not working here. So let me just quickly see what is happening, and I will try to showcase this specific aspect. Yeah, give me a second. So I think the instance kind of went down. Probably that is what is happening. So let me see if I can like open it again. Yeah, usually these links are valid for just a couple of minutes. So probably that has happened and the link kind of expired. Cool. Let me see. I think I might have another instance which might not be that sophisticated, but that could possibly work. Okay. Yeah, so possibly what I can do is showcase some things which I think I kind of ran early on, and then see if I can showcase some things on the live. Um, but yeah, let's see. In general, this is a multi-agent kind of system, right? So I can give it like any query and it should route to appropriate kind of agent. So some of the query I was running just like an hour ago. Let's see. So the first one was about a Samsung smartphone, maybe under like 50,000 rupee Indian rupees or something. So as we can see, this query is about a product. So it is kind of routing me to a product agent, right? So it can give me like various details about the product. So this is something like you might have seen in the code. This is something like we were kind of formatting. Then maybe I asked like the tech spec of the iPhone 15 Pro. I think one of the things we had seen in the code is that we had like various fallbacks. So let's say iPhone 15 was not in the database. So it will look for other products which might match some of the keywords, right? So now it is kind of it's still a product agent and it's kind of showcasing me details of different product. We can make it like as sophisticated as possible. If we want like exact match, we can do the error handling and things like that. Then if I give it some order number, we see that the order agent is kind of invoked. And then it can give me various details around a specific order. If I ask the return policy for some smartphone, it is able to pick up that this is about like some return procedures, right? So then it is being routed to the return agent. So yeah, in general, I think the concept is based on the query, I'll be kind of routing it to appropriate agents, and then those will be able to like handle the response. And then I can ask it like more follow-ups. It'll have the memory of what I had asked like previously, so it can build up on those kind of responses. So I'm just like trying few quick things on the side. Uh, Potentially, as with any live demo, there are some hiccups, but I'm trying to see if I can quickly showcase you something more live. So let me see if this is working now. Um, Cool. So this is a pre-built query, but like one thing to see here is the visualization we had, right? So in this case, it is a pretty kind of basic visualization, right? So there are like two nodes. A user is sending the query. It is about product specification. So it is routing it to a product specialist. This is a very basic demo, but usually in enterprise setting, we'll have like tens or like hundreds of nodes. So that's where like seeing this kind of relationship is really helpful. In case something is not correct, these kind of visualizations could like really help us in identifying the um, uh, right kind of error points. And then let's say I ask something around the orders. Now the graph has changed. Now the user query is being routed to the order specialist. And let's try something around the return policy and see if the visualization changes. Um, so yeah, in general, this kind of visualization could be like really helpful if we are trying to debug anything after the fact. Cool. Yeah, so I think with that, these were the details which I had planned to share.